Hey guys, welcome back. We're gonna keep going with the biochem. So I'm gonna do both 3.3 and 3.4 in one video, just because I feel like it should be protein isolation and analysis. So let's start with protein isolation. So electrophorese is when we have movement of proteins in electric field, and again, electro, based on size and charge. Okay, definitely know. Definitely note. I will say these next two, 3.3 and 3.4, are like 10 out of 10s. You do need to know these like the back of your hand. So we have two different types, right? We have phage, which maintains protein shape, okay, and is separated by size or charge, okay. Now we have a different type, SDS, which I think is sodium something sulfate. This denatures your proteins and separates them by molecular weight. And again, I was actually just doing a U-word passage and I saw that exact thing. So next we have chromatography, and it separates by physical and chemical properties. And again, you should definitely understand these types very well. So column chromatography is based on polarity. So again, let's say that you have a column that's negative. Like non-polar or polar. So let's say that you have silica gel, which is polar, and then you put something in it. The polar molecules would get stuck in the beads, right? And then you would only get the one substance that you need. So next we have ion exchange, and these are based by charge. So again, it's like anion or cation, and then same thing, right? Whatever the chromatography anion, the anion comes out first, and the cation comes out first. Size exclusion, obviously by molecular size, and big molecules elute quicker. And then affinity, based on how much it wants to bind to an antibody or a ligand. So next, we're going to go into protein analysis. So first, we're going to start with structural determination. So first, we have X-ray, right? So this is most common, and then you get the highest resolution. And we have NMR, and I love NMR. Total side note, but I love NMR. But it is less common, and it really is only useful if crystallization fails. Next we're gonna look at amino acid composition. So element degradation sequences all small proteins, and to see protease plus mass spec is used for larger proteins. And activity analysis, we measure enzyme function via known reaction, okay? So again, like fluorescence. And then now we go through concentration determination. Now I feel like these are pretty important. Now I would say they're like medium important, like I've seen them before, but not a lot of it. But you should definitely understand this with the aromatic amino acids. You will get questions with certain absorbances and be asked what amino acid matches this peak. And if you need to know that aromatic amino acids absorb at 280 nanometers, okay? Definitely know that. And then you should definitely know about Bradford assay. So dye binds to proteins, more blue, more proteins, okay? Very straight up. And that's it for protein analysis and protein isolation. Again, two very important things. If these explanations weren't the best for you, that's fine. I would still recommend you find something that works for you. 100%. If you don't know this, just don't take the test. So next, we're going to get to chapter 4. And chapter 4 is all about carbohydrate structure and function. So I'll see you there.